Welcome to Cpp.chat, a solid look at what's going on in the world of C++, chatting with guests from the community. But before we objectively examine our guests' principles, John has some designs of his own.
Thank you very much, Phil. Much of the information on Cpp.chat, articles, recipes, medical information, advice, etc., is transcribed directly from antique sources, most over 100 years old, and should be considered for entertainment purposes only. Methods described and ingredients listed in articles and recipes may now be proven dangerous or even illegal. We do not make any warranties about the completeness, reliability, and accuracy of this information. Any action you take upon the information on this website is strictly at your own risk, and we will not be liable for any losses and damages in connection with the use of our website. All right, thanks a lot. This is great. We've got a couple of great guests. Tony Van Aert is on, and Klaus Eigelberger. Tony, have you been on the show before?
Once before, I think.
Okay, and I'm
pretty
remember,
sure Klaus you remember it so well.
Well, there's been so many.
It was just a couple of episodes back, right? 4, 5,
yeah.
6. Yeah,
that's right. Well, a couple of episodes back is about 6 months ago. So that's all right. So I'm sure we have a solid purpose for you guys here. What is that?
Well, I guess the solid principles, right?
They're not 100 years old though, like your recipes. It's
that's right.
It's not that old.
A significant proportion of that, though.
You've pointed out it's exactly 20 years old. And when I say you, those of you who don't know yet, Tony's going to be giving a keynote at C++ Now on Solid. But both Phil and Klaus have also given Solid talks. Is this news to you, Tony? Somebody should have mentioned this to Tony before.
I should really work on those slides.
Yeah, and everyone is expecting it to be an iambic pentameter. So that's
You're the odd man out there, John. Where's your Solid talk? Right.
Well, I didn't give a talk on Solid, but I did give a talk on object-oriented programming. And the reason I did it is because I feel like, I think I have a pretty good pulse of what goes on in conferences, and there's not a lot of talks on object-oriented programming. In fact, that's a pretty good way of seeing to it the committee doesn't approve your talk, as to say. In fact, there's one particular talk from one particular speaker. I'm not going to mention any names, but he's actually doing something kind of innovative on this, and but it's object-oriented programming, and he can't get it through a committee. And I keep trying to help him. How can we do this, right? But the problem with that is that I know conference talks are about 10 years ahead of where training happens to be because I do training. Klaus is nodding his head. I think he probably is about the same situation, right? But even where training is probably, 10 years ahead of where code bases are, which means that most people who are doing C++ professionally are maintaining at least one code base that has an object-oriented framework in it. Maybe it's mostly an object-oriented framework, or maybe it's just part of what we do. But object-oriented programming has some gotchas. C++ is not easy no matter what you're trying to do, and I don't mean it to be derogatory, but I mean it's a language designed for professionals, and you need to be professionally trained, and you need to have experience, and you need to have good practices. And if we in the conference world are talking only about static things and only about the latest features, then we're missing out addressing issues for the bulk of C++ programmers. And the problem is that that's not really a problem if people are the age of some of us on this podcast, because we learned this stuff a long time ago. And in some cases, when people use the old thing, he's forgotten more than you'll ever know. In my case, I've forgotten a lot. So
the weird thing is that we at least some of us sitting here probably started programming before Solid was known as Solid.
Yeah,
right.
That's true.
That's why when I started hearing about it, I'm like, what is this? And then I'm like, you look into it. I'm like, oh right, I was already programming before the term came out, and that's why I didn't hear about it, because I felt like all these people came from somewhere that I've heard this, I've learned this, and I'm like, where have I been? It's like, it didn't exist.
So my concern and what motivated me to give my talk was that best practices for object-oriented programming was not being discussed at conferences. It's still in the books, but by the books I'm talking about obviously Scott Meyer's books, but also Herb's books and other people's books that were written for classic C++. So nobody's recommending them now. I even hesitate to recommend them, even though 90% of what they say is still key. The problem is you don't know which 10% if you're not knowledgeable. I mean, you and I could look at that and understand, well, this isn't true anymore because we did this in 14. But most people who are learning it for the first time aren't going to realize, no, Scott's advice, which is usually 100%, is not really correct here because we changed something in the language.
I always tell people that Scott Myers is a graduation process, right? When you get to the point where you go, wait, Scott wasn't right about this, right? Because in this one situation, it wasn't the best advice. It's like, okay, you've graduated, but like it is solid in the different sense. It is solid advice,
Yes.
Like you said, 90% of it is if you're not sure about what you're doing, then just follow what Scott says. And then once you learn all this stuff, you will find the places where oh, okay, now I understand everything. I understand why this doesn't work in this situation.
So what I've been wanting to do is champion object-oriented programming best practices. And again, and I say this in my talk because my wife did ask me this. She said, John, did you really want to become the object-oriented programming expert? It's like, I'm not sure I want that. Because I'm not an advocate of object-oriented programming in the sense that if you're starting from scratch right now, maybe value semantics, compile time things, this is the way to do things, not to do runtime dispatch. So I'm all on board with that. But my point is, we don't throw away all our code every year and start from scratch. If we did, we probably wouldn't be using C++. The point is that we maintain old code. And in order to maintain it and expand on it and to add new features to our code bases, we need to understand object-oriented programming and best practices of it. So that's why I've been talking about these issues. And I'm not cutting any new stuff. I'm showing you the classic stuff. At least in my talk, it was all about, I constantly made references to, if you want to know more about this, here's Scott's book and here's Andre and Herb's book or something like that, which dealt more in more depth on these issues. So, but I don't want to forget. And I think that's like I say, it's overlooked and we need to do more about it. That's part of the reason actually why I did the Back to Basics track at CPPCon was to try to recognize that although conferences are doing what they should do, I'm not being critical of conferences, when we show the latest stuff and the cool way you can do it and all that gee whizzy stuff, but we also aren't doing our job if that's all we show. We also have to be a place where people who are still going that graduation that Tony's talking about, becoming the Scott Meyer educated, then we got to help them with that stuff too.
Sorry.
Go ahead, Klaus.
I talk to prove two things. So first of all, I think there's a lot of misunderstanding about SOLID. This is something I wanted to clean up, or at least give it a try. The second thing is actually that I do not believe that it's just object-oriented programming. I believe you can use these principles just as well for functional and generic programming. And I gave a couple of examples. It actually works out pretty well. Basically has exactly the same meaning. So I would consider it as design principles, not as object-oriented principles.
That's I mean, to give it away, that's my talk is the reason I decided to do a talk was because I don't like SOLID. I just like all the individual letters, right? Like you look at every letter, I'm like, okay, that makes complete sense. Yep, Liskov. Who's going to argue against Liskov? And whatever. And then I'm like, but how come it always comes out a certain way? It always comes out with too much derived interfaces and too much, and they make sense where they make sense, but it becomes the only tool in the whatever, and it gets over applied, right? So yeah, it's how do you balance the value oriented and the object oriented? Because I have don't tell Sean Parent, but I have objects in my code base. Yeah, I know. In particular, like in my code base, I have cameras and projectors. That's what I do, right? We do stuff with projectors. So a projector really is an object that you can't just make a copy. I wish I could just, by using the copy constructor, make another projector, but they take a lot more effort than a copy constructor. So a projector is an object, and so is a camera. And certain things are objects. Buttons are objects. You don't want to copy a button when you pass it into a function. And then other things, no, right? And what I find is if you're working with an existing code base, is you work your way from the bottom and find your types that are fundamental vocabulary types in your code base, right? Like no one uses vectors as objects. Vectors are values. And I have, what do I have? I've got, camera intrinsics, which tell me the focal length and all these, it's like a dozen parameters about a camera. That's a value, right? It's like you can make copies of that and you pass that around as a value. It is not an object that you want to pass as by reference and
I want to point out
store references to.
You're driving me crazy with your term object. I understand what you mean by object. You mean something that's in an object-oriented hierarchy. But to me, I always think of object as essentially, it's just a value. It's just a thing that encapsulates a value.
Well, yeah, that is
so
the
I understand what you're saying, but it's an impedance as I listen to what you're saying.
Yeah,
you're saying as opposed to a value type, an object type that has a virtual
semantics.
An interface and a virtual override situation somewhere. Okay.
Yeah. Well, and it's not even that. And, Sean always does better than the rest of us. Sean talks about value semantics and reference semantics. So if you take an integer and you make it a global variable, it's become an object. It has reference semantics because the whole world can see it, everyone can access it, and it's like this integer right here, right? It's not a value that's being passed around. It's like, nope, it's this integer. Where's my finger? There it is. It's right here on the wall here. I've got this
Your finger
integer.
is not an object.
Yeah. And it becomes everyone references it. It becomes reference semantics, right? So anything can be an object or a value, but when you write a class, you tend to, have a thing in mind of this class is going to work object-ish and be to me an object means it has identity, right? It's the projector, not a value. Values don't have. Well, philosophically, there is only one number 17. It's the number 17. But ignore that for now. The number 17 just passes through your code, not as a reference thing.
So I will say that although, as I said earlier, I'm not advocating object-oriented programming. I think that the modern techniques of doing things with value semantics and doing things at compile time, these are wonderful and huge things. But I will say this. I have much less experience doing this. I am, because of where I came from, I'm an object-oriented programmer. And in my head, I can code up an object-oriented idea, a design. You give me any problem, and by the time my fingers hit the keyboard, I already know how I would do this in an object-oriented way. And I have to sit back and think, okay, now wait a minute. Maybe there's a better way of doing this with compile time rather than runtime dispatch. And I think about the designs differently. And that's actually, I had this conversation with Sean about this. And I said, how could you write something like Photoshop, which is this, huge object-oriented application, and nobody's going to rewrite that overnight. That's just not going to happen. But how could you have, if you had started from scratch, how could you write that in a value semantic way and not use object-oriented programming? And what he told me, and I haven't seen it in practice, but I think I have the germ of what he was trying to get to. But he was basically saying, we've done some of this, and what he uses is essentially type erasure. So that what happens is you have, instead of having a camera, which is what you're talking about, you just have something that's a recordable, or I don't know how you would abstract what a generic camera is. But the idea is that you actually are using object-oriented programming as an implementation device. In other words, inside of this thing that is a recordable value. So it's actually a value type. It's a recordable. But inside that, there is an object-oriented implementation so that your recordable, which you treat as a value, you can put it in a vector, you can do whatever. But what it has inside it is something that could be could be derived.
The thing is then what you get then, it of course it always comes down to naming. You no longer have a camera, you have a camera reference, right? Because if you do make a copy of that, does it, both camera references talk to the same camera, right? In the case of a camera, like maybe it's different with a Photoshop document or something like that.
Yeah.
But I mean, I'm in a weird world of half my objects are physical objects. If you're in a world of pure code, like Microsoft Word, everything is virtual objects, right? So yeah, you can make a copy of a slide and that has meaning, right? But I can't make a copy of the camera. The weird part is that move semantics solve some of those problems for us, right? Like when my camera object, I can make it more value-like if I just make it move only. And then I kind of get kind of a bit of the, both worlds kind of thing. I don't want it to be a pointer. I want it to clean up after itself when it goes away. But I don't want two cameras unless I do want two pieces of my code talking to the same camera. Then I will rename it to be a camera accessor or something like that, and allow I'll call it a shared camera accessor. I'm starting to sound like a Java programmer. I just add. All right, I'll shut up.
No, I guess I see what you're talking about. I think what Sean was getting at was, I don't think we discussed that case of where you're trying to model a real world object. What he was trying to free us from was essentially the hierarchy. In other words, your object, this camera object, is no longer derived from this thing. And this is one of the things with early, and I know because I was there for a lot of the early object-oriented programming, is we were going to make reusable code. We wouldn't have to keep recoding the same stuff again. We're going to create this reusable object. But it turns out that object's only reusable within the context of a particular framework. And so you couldn't do this work over here and then say, oh, we've started a new framework for a new application. Can we just move all the code over? And it's like, no, we can't. But in a volume semantic world, yes, you could, because it just has to compile. We do it with templates and things like that. And I think that's what he was saying is, and the example that he has a great talk, which by the way, I think was actually given by somebody else, but he credits that Sean wrote this talk, but he's not feeling well. And so I'm giving this talk. Anyway, the talk talks about this thing called a printable. And you can actually put together these printables, and you can have a printable that is a collection of printables and all these kinds of things. But of course, every time you treat it as a value, and every time you copy it, take a snapshot of it, of course, it's not referencing a real world thing. So I hadn't really considered what would happen if you actually have a camera and you literally can't copy it, in the sense that, if I copy this camera object, do I have two separate physical cameras? And clearly I don't.
By means of this type erasure, you indeed glue an external hierarchy to it. This is basically the trick. So inside this type erased object, there is a hierarchy.
Right.
Which you artificially add to it. This, by the way, a design pattern. It's called external polymorphism, which is not Jean's invention. So this was, I believe, invented in 1996. So in the time when there was a lot of object-oriented design patterns, this was just one of them. And I believe this was now rediscovered as something that truly works pretty well. You create this type erased type, which acts as a glue, and everything else is kind of duck typing.
Mm-hmm. You can go back to boost any. Boost any was one of the first type erase things, which is based on something from Kevin Henley. Kevlin Henny.
Yeah. So he wrote a paper in 2000 called Valued Conversions, I believe. This is the first time I saw any. So in 2000 already.
Yeah, I remember the first time I looked at any, and it's like, wait a minute, this is not a template. This is the whole type. The type is just, but wait a minute, how can that? Yeah, it took me a while to wrap my head around that, and I didn't realize the history that you were just telling me, that this was what did you call it? External polymorphism.
That is the design pattern that Kevlin uses in his any implementation.
Right, so. And that's what Sean was using for his any printable. I mean, he obviously even used the same name, any printable, and so. As I said, I've never seen an entire framework done that way, and I suspect it might fall apart to the extent that you're trying to model real-world things. I mean, this is one of the reasons I think that object-oriented programming works so well for a GUI, is that you're modeling, they're not actually real-world things. You have a button on the screen, but it does have the physical properties that's what it's emulating. And, if you copied that value, do you now have two buttons at exactly the same location with the exact, what does that mean, right? But I think that's why the glory days of object-oriented programming were also the glory days of new GUIs, and I think they are.
Yeah. The important part here is that you're telling me that I could ask Sean for slides, and I could just do his talk. That's what I heard. That's what I heard in the story.
That's exactly what I said. That's exactly what.
My plan so far has been to get Phil's slides and Klaus's slides for their solid talks, because that would save me a lot of problems.
A copy of the slides.
Yeah.
Or a reference to them.
So you talked about names a little bit, Tony. I'm curious what you think about the solid names. You said you like every one of these names, or every one of the letters.
Yeah.
Don't you feel that the names of these solid principles are misleading?
Well, I have to think about that. But yeah, I always get the last two mixed up, right? The I and the D.
Bob Martin got the last two mixed up.
Because they always get, and I'll tell you now that my talk's going to end up, same with, speaking of Kevin Henney, he did a solid talk as well.
Mm-hmm.
And I noticed that mine's going to end up the same way. You spend half your time on S, and then you do the other ones, right? and single responsibility is a great idea, but it basically it comes down to, write your code well. It's like, yeah, okay, but I have a class in my code base called model, and it has one responsibility, and that is to hold everything. So it only does one thing. It does everything.
It's exactly what I have in mind. So single responsibility, that the name basically means something else, is something different to everybody. So this is not really a name that you can grasp. It's very vague. What is a single responsibility?
But I see it so much because I write this class that is just perfect, and then I realize, I should add this other thing, and for this case I want to have this, and then I see it when it fails. I see it very clearly when it fails.
Yeah, it's there's the famous Justice whatever quote of I know it when I see it, right? I know when you've broken single responsibility. I can't tell you what it is, but I can tell you when you've broken it. Right. I can tell you what obscenities are of single responsibility.
So the single responsibility principle was actually derived from the work of Tom DeMarco in the 70s, and he called it cohesion, which I think is a much better name, much more useful as well. You can actually do something with that once you understand what that means, which is
but
basically the things that
should go together doesn't make
together.
any sense. COLID, like what is COLID? I know what solid is. I don't know what COLID is.
But perhaps in your talk, if it's truly a keynote, you can try to push people towards other names. And perhaps this is all it takes.
Yeah.
Because else there is people like Kevin Henney who destruct the solid principles. I believe mainly this is about the misconceptions, about the bad names.
Yeah.
Yeah, the naming is a big part of it.
I've got too much to do in my talk. I have to describe what they are, then describe, half my talk is going to be this whole question of what are they when you're talking about values versus they do tend towards object-oriented. And if I want value-oriented, what do they still mean? And I think they still do mean something. But yeah, I keep looking at it. It's like, how am I going to fit this all in? That's the stage I'm at, right? Like you're at the stage at the beginning of like, I don't have enough to talk about. Then you have too much to talk about. And then.
But you do not have a strong feeling against one of them, right?
What's that?
You do not have a strong feeling against any one of them. Yeah, because Kevin, for instance, had very strong feelings against, I believe, almost 3 of them, perhaps even 4. So he was just promoting the S, and he was kind of discarding all the others. What's your take?
There is only S, and the rest are ways to get S, right? It's not even S isn't in my head isn't single responsibility. It's separate. I do have another acronym. It's KYSS, which is keep your stuff separate. Like that is all. That is what programming is all about, right? Whatever it takes to keep your stuff separate, and these pieces help you, like Liskov or something like that. Just make sure you did it right. But open close, I guess, is an attempt to keep your stuff separate. Open close goes against vocabulary types. I think it's the one that goes against vocabulary types, right? Like And all these things push you towards make an interface here so you don't depend on anything. And that's a way of keeping your stuff separate, right? But eventually you realize that you have fundamental types in your code base. Like no one says, don't use strings, use a string interface, right? It's like, no, you just pass strings around. I mean, actually what we did was we made string view, which is a string interface, but it's still,
and that does depend on the language. There are some languages where you do just deal with a string interface, and there are different implementations that are very effective at being more optimized for certain cases. And you never actually get to see that.
The other example is if I want to do an address, so I've got employee record and it has an address and blah blah blah. It's like, okay, well, let's make an address interface. So I need get the street you live on, get the city, country, get. It's got 7 parameters in the get address interface, and then the employee record will have a get address and it implements the get address interface. Great. So now you pass an address interface. It could be from an employee or it could be from anywhere. And my function works because it takes a get address interface or an address interface. Okay, how about the get address interface isn't 7 functions that return individual base types. Instead, the get address interface it returns an address. An address is just a struct with 7 values in it, right? So it's these small structs that to me is the key to everything, right? So the function that needed the address interface because it wanted these 7 values, it doesn't take an address interface. There's no interface. It takes an address as a value. I don't care where it came from. It's still separated your code, but I didn't. Yeah, and the problem with it is I now have a dependency on the address data type,
which is
instead
your
of having
vocabulary
a
type.
Yeah, right. And that's the point. It's okay if it's a vocabulary type.
Right. As a practical matter, if you have something that is heavyweight, then making an abstraction on it, like maybe your camera situation, instead of having a camera, you have some, camera holder or camera reference or something like that. But the problem is if you decide that, well, every numeric value in my application, instead of having an int or a double, I'm going to have some numeric value reference that could, in Python, my understanding, I don't know anything but the internals of Python, but if you have an integer and it overflows, they automatically flip into kind of a big implementation underneath the covers that you don't even see. It just happens magically. And there's a cost you'd have to pay for that that a C++ programmer would never accept. But it's a beautiful logical abstraction that a number is just an interface, right? And we wouldn't accept that for vocabulary types, for those low level, used everywhere, gonna have lots of them in my app kind of app. I'm sorry, Klaus.
I still would argue that OCP is not necessarily about creating abstract interfaces. It's not an object-oriented programming thing. So just to give a couple of different examples. So Phil, for instance, in his catch library wants to enable me as a mere user to do some extensions. Well, he has a couple of choices. He can actually create an abstract interface that I derive from. Great. I have something to do without having to change his library. But he can also just provide a couple of, say, free functions that I can overload for my types. For instance, to serialize some stuff. Perfect. And the free function suddenly is giving me opportunity to extend it. That's what OCP wants. So no abstract interface here, but just a free function.
It's now compile time, right? It's now compile time instead of runtime.
Correct. Yeah, suddenly totally different, but I think it fulfills the principle. It could also, for instance, write a function that takes a stud function. This is also something where I can plug in my stuff. I don't have to inherit from anything. There is no interface, but still he has given me some way to extend the code without having to change catch to itself. I think this is OCP. It's not necessarily about inheritance. There's a lot of ways you can do that. And I think that
by OCP, you're talking about open-closed principle. I'm sorry.
Correct. Yeah, sorry. And
I think Mayo did
actually. Sorry, Phil.
He talked about OCP for even for functions. So supporting what you're saying about it, not just being for class hierarchies.
Yeah.
So I would really argue there is more to OCP than just base classes. It's also, I believe, more than just keep your stuff separate. Yeah, this is advising Phil to write his library such that I can extend it in meaningful ways without having to touch his code. There's multiple ways. At least this is how I interpret it.
Yeah, but that is done so that you keep the code separate, right?
Well, Phil's stuff and my stuff should be separate, right? This is not just my.
Yeah. So that is the goal. And the goal is to keep your code separate. And the underlying goal, which is if you go read the original solid things, the goal is all about change, right? It's like
correct.
Which part of your code is going to change?
It's not about change. It's about extension. Change is SRP indeed. I would argue OCP is about extension.
Oh yeah, I just mean solid in general is about change.
Okay.
It's about managing change, right? Well, OCP is you don't want to have to change Phil's code. If you wrote it differently, you'd be like, oh, I have to change Phil's code to get my code in there. It's like, correct. Oh, you shouldn't have to make the change you want to make, which is add whatever feature you're trying to add. You should only have to change a small amount of code, right? It's like, if I have to go and change everything, I'm not going to do this. Right?
Correct.
And that's every piece of solid leans back on, I don't want to have to change more code than I have to change, right? Like minimize the change of the code. My other example there is, and I think you used similar examples in your stuff, like a circle. You always see the circle shape, draw, all that kind of stuff. And
I apologize for that, by the way. People criticize me for you always using shapes, rectangles, etc. But I had 60 minutes to squeeze in 5 solid principles. 60 minutes only. I believe a simple example is actually a clever choice.
Yeah. And if you look at circle and you look at draw and all these things, and you go, okay, what's going to change? The mathematical definition of what a circle is, or how I draw it, right? Like, I draw it using OpenGL, and then I switch to DirectX, and then I switch to CUDA, and then I switch to whatever, right? So having a circle class that knows how to draw is a bad idea. The circle class has a radius. That's all it has. It doesn't even have an XY, because the XY location is extrinsic property of a circle. It's not intrinsic to the circle. It's a relationship the circle has with, the layout or whatever else. So you can write a circle class that will never ever change, because partially because it's an easy one. It's easy to know that circle's not going to change, right? Except for you decide that your radius should be a double instead of an int or something like that. But it's easy to get that right. The problem is in other code that's not based on math or something, you're guessing as to which part is going to change and which part isn't going to change, right? I found in our code, every interface we have, the interfaces aren't closed, because, well, we just got a new projector, and this new projector does this new feature. Well, I need to add that to the interface of projector, because I need to turn on 3D color something, right? Well, and what I end up doing, instead of changing that in one place, I change it twice. I change it in the interface, and I change it in the implementation, because I've got this interface separation. It's still the right thing, because I have 8 different projector implementations, because 8 different types of projectors, and maybe I only need to implement it in one, not all 8. So it's still correct. But you get these cases where it's like, I find myself changing the interface more than anything, and you've either guessed wrong at what you're always all your design is based on what do I think needs to be more malleable and what doesn't. And sometimes the answer is you can find things at the bottom level, like circle, where you're like, this is solid in the not capital letters sense, but it's like, this is unchanging, right? A circle is a circle, and it's always going to be that. And like an address or something like that, it's like, okay, maybe addresses subtly change, but you can find these things that are the basics of your program, and you say, this is not going to change. And then at the top level, if you do it right, you can also find things like the program I work on aligns projectors, right? You put projectors onto the wall and you align them so that they look like one projector. And if you say that's the fundamental design, and you write all your code based on we align projectors, you end up with one set of code. if you decide that no, our very general purpose is to put pixels in the right place, then you will realize that okay, this is a problem that's not going to change as much over time. So you can find the right abstractions. It's not even abstraction. It's just like define your problem space correctly, such that I've tackled a very much more generic problem of put pixels in the right place. And now my design will not change because I've taken on a way bigger scope than I'm actually going to do. So I'm not going to do that full scope, but all my designs will make sure that it can grow into that, because I thought from the beginning of like, you know, and it kind of goes against it. There's a conflict with just write something and see what people want, right? Like, just get the first version out there and realize that it's going to be wrong and people are going to tell you what they want. But at some point you have to also have a big picture in mind of, yeah, my general idea is I'm solving this very, very generic world of problems, and I will go in any direction the users tell me inside this world. And if I get that right, then the big level design doesn't have to change. And if I get the small pieces right, the small vocabulary types hardly change because they're easy to find. And it's just the middle stuff that gets to be messy. And that always happens.
It absolutely does. But I feel like when you discover something changes often, this is again the opportunity to do some SRP. To draw it out, separate it somehow, because apparently this is something that is malleable, as you said. Perhaps this is then the indication. And then again, the principle helps.
Yeah, and there is a fundamental difference between when Solid was first coming into being. It was harder to change code, right? The compile times and I don't even want to change this header file because it's gonna, and not that we haven't solved the compile time problems yet, but I think people now have this idea.
Everything.
Yeah, for sure. We're now in the state people realize no code is unchangeable. Just change whatever needs to be changed, right? So you also your cost function of like, well, where is it going to be painful to change this or change that? It's like, if you refactor enough, nothing is, just change whatever you need to change. And
yeah. That's why software is called software.
Yeah.
From you can change it. This is the expectation.
Well, except that there's constraints on that. If this is a library you're shipping or a framework you're shipping, and you've got lots and lots of customers, and then you realize, oh, you know what, this should work this way instead. It's just going to break all our customers' custom built derived classes. No, there are costs to changing some stuff, and that's why thinking about in advance, what do we want to, what are our customization points and what are the ones we want to support? And I think, one of the things that the standard library kind of ran into is that there were customization points that were not designed to be cut. They were just incidental. It's like, well, if you change, you create a specialization of this type, then this algorithm will work differently. And that wasn't really the design of the algorithm. That wasn't the intent, but you've done that. And I think that thinking these things in advance and being explicit and saying, these are the customization points and these are the kinds of things we can change. I know from my experience where I've done a brilliant job of designing classes so that things can be customized in certain ways, that I almost always manage to completely overlook what's going to need to be customized. In other words, I remember having designed this thing and it was very clever about how this could be customized. And in the entire lifetime of that hierarchy, I don't think that was ever changed. On the other hand, all sorts of things that I had baked in, those things were the things people said, well, could we actually change this? It's like, oh, okay. So I really think that the brilliance is someone who has done, one of the things that Alex said about generic algorithms is that you don't create them, you discover them. In other words, what he's saying is you survey and see what else is done. And I think that's kind of what you have to do with object-oriented or any kind of application level like this. You look at what everybody else has done, and then what has to be changed because you've seen it change in all these other situations. And someone who thinks, oh, I'm going to write this down, and nobody's ever written an application that does this before, but I'm going to accurately predict all the customization I'm going to need or the kinds of customization, and I'll build those in. I just don't think. I mean, we're arrogant enough to think we can do that, but I think we should be humble enough to recognize we can't do that.
Agreed. Yeah.
The when I was working on Adobe Premiere, Adobe Premiere has media files, right? You got your audio, your video, and media files have a duration and frame rates and all these things, right? And it's like, yep, that's what media has, right? And then I was working on titling and things like that. And they're like, okay, what's the frame rate? And I'm like, whatever you want. Titles don't have frame rates. Even like a rolling credits, how fast you want them to be. I can do that 1,000 frames per second if you want. I just run, it's virtual. I can render at any stage. And then it's like, well, what's the duration? Like all these questions are like, no, these are not, you fundamentally are missing the abstraction. But then if you go, David Sankel gave a talk years ago at C++ Now, or might have been BoostCon, it was that long ago, about EGDA, which is a crazy, good, cool language, EGDA. And he asked, what is really the definition of a movie? Like, what is a media over time? And it's like, it's a function that takes a time point and returns a value, right? It might return pixels, it might return audio things, it might return whatever. Is a function that takes a point in time and returns data back. And it's like, yes, okay, that is the correct abstraction for what media is. And well, let's not talk about what Premiere had inside its code base, but
Are you suggesting it wasn't that?
It was getting there, but yeah, and it's I don't know. Is it that hard to see that that's the right abstraction? I think once you
that's my I'm going to say yes. It's that hard to see until you've seen three or four different implementations of that, and then someone comes along and says, I've got it now. I know what changes and what doesn't change, and I can design the ultimate. And I don't want to say framework, but logical hierarchy or logical structure in which we've defined the media in the correct way. Because as you said, the initial attempts are going to be, well, what is media? Well, I have this format and it has, frames per second, and it has,
You want the sad part? You want the sad part? This was Premiere version 7. We already done 6, and Premiere 7.0, which became Premiere Pro 1.0. It was a rewrite. This is a great story. Essentially, when I started at Adobe, I was doing the magic trick. I was doing the magician's other hand. Get my hand in here, right? Where it's like, hey, look at this cool new feature, a new titler, blah blah blah, in Premiere 6.5. Meanwhile, the rest of the team was rewriting Premiere from scratch, and we needed time. It took like 3 years to rewrite Premiere, and so we needed a release in between. So I came on. My first job was to write the last version of the old Premiere. And me and it's a team of guys. And when because the old Premiere code was unmaintainable, it really was. And they went to upper management and said, we can't go on. We need to rewrite this. And management said, okay, there's been a number of products at Adobe that have tried to do a rewrite, and they've all failed. So you have 3 years, and when you fail, you're all fired. And it wasn't an if. It was like, you guys are going to fail, and you will probably be all fired. So go ahead, but and you'll have to have a dot release in between so that you're still making money at the year and a half point. But if you can't get it done in 3 years, you're done. And I mean, we did. We shipped Premiere Pro 1.0. It was a rewrite. So some of it, I thought like that was our opportunity to get a little more better abstractions, but. On the other hand, maybe if we had spent more time scratching our heads about abstractions, we wouldn't have got it done. So we got something much better than what we had. So, and in long since improved since then too.
Okay, then talk about abstractions. Let's hit on a solid principle again. Let's pick the D, the dependency inversion. What's your take on that? Because this is, I believe, the one that is most complicated, most complex for everyone. So for me, this is not about separating concerns. This is truly about who owns an abstraction. Who is the one who is in control and who can change this abstraction? And if you put that right, you actually might have, indeed, a much better life when you change things.
Yeah, I think that's where I probably should have talked about that when I was talking about vocabulary types. I find that we try to depend on, like, that, you know, the thing says depend on abstractions instead of concrete. And like, you know, pick your concretes. There's a lot of concretes that I don't mind depending on, as long as they're very concrete, right? Like an address, and that's all I find in my code base is even in the UI. I did the talk last year on value-oriented, and it's kind of like what John was talking about. It's value-oriented programming in an object-oriented world, right? And Wanpei Bolivar did almost the same talk, same title, right? It's once again, just like this solid, Phil and I have the same titles. We had the same title and the same point of, like, you're living in a world of all the current code is object-oriented, and I want to write some value-oriented. And I was tackling, most of my talk was tackling the UI portion, right? And you end up with a lot of code that's like, oh, you know, the value of this button or the value of this integer in the UI, you know, I've got left, right, top, bottom of, like, the coordinates of my projector. And that's 4 values. So you see a lot of the code that sets one value to the UI widget, and then sets the other value to the UI, and it's working at the lowest value level of integers or floating point, whatever that thing is, you know, 4 ints, but it does 1 int at a time. I'm like, okay, make a struct that's called projector extents, and it has left, right, top, bottom, or whatever. It's, you know, and just work at that. That's just a tiny bit higher than working at each integer individually. And the projector extents don't need to be an interface. They don't need to be an object-oriented hierarchy or anything. It's just these 4 values go together. And now your UI, and the point is, I'm okay with the whole world depending on that header file, because that header file has no other dependencies. It's just a struct with 4 values, and maybe it's a, you know, depending on whether it has invariance or not, maybe it's a class with private variables, or maybe it is just a struct with public variables, because there's no invariance. I just find that suddenly your code works, all your UI interactions, you pass these 4 values together, and maybe you can go up one level higher of, like, projector info is a struct that has the projector's extent and the projector's position and a few other things, but it's still a simple class, so I don't mind depending on it. But then at some point you'll get to another level of, yes, this, you know, I don't want to depend on projector has to be an interface because I have multiple implementations, but I've got a lot of interfaces in my code that have 2 implementations. One is in the code and the other is in the test program, which is cool that I can test these things. But it's like, every time I make a change to the interface, I make it in 3 spots: the implementation, the interface, and the test program. And I'm like, this shouldn't have been, there was no point to this interface. It should have just been a dependency. Straight up, I depend on this other thing, because either I depend on the interface or I depend on the implementation. I want to depend on the interface when there's 10 implementations, not when there's only 1. You didn't really gain anything, right?
If you change the interface, of course. Yeah.
But the challenge, of course, there is that if you're
knowing which one.
Well, if you're creating the application, I took a class, and I won't go the whole thing, but one of the things that the instructor was doing was really, really violating this open-close principle and doing it really fundamentally. And it's like, why is this working for him when, you know? And I realized what he was doing is he was doing a certain kind of modeling where he was writing the library, but he was also in charge of the application, and he could come along at any point and say, because one of the things he was talking about is, make the assumption it's always this way, and if it isn't, we can change it. And 98% of the time it was that way, and then the one time he could change it. But if you're actually making a library and you're saying, well, I'm going to ship this library, is there any user that's going to want to customize this? And if there is, then it has to be an interface. And that is that's a thing. If you're actually going to say, well, open closed, you have to really be committed to open closed if you're shipping your framework and you're going to have thousands of users and they're going to do it. On the other hand, if you're doing this yourself and it's for, it's purpose built for you, or even just your company, maybe you have 3 users, but there are 3 products within the same company, and you can always go to that team and say, look, this is the plan. We're going to make this change. Be ready for that because, as of this point release, this is the world you're going to live in, and be prepared. And you can violate the open closed if you're in that situation. So, and the cost of being generic on every, everything I do is customizable. Well, that's a really expensive way of approaching the world. There's lots of complexity and even performance that you're going to hit when you start to do that. But if you can simply say, no, we'll just assume this is always true, and if it's ever changed, we'll change it then.
Can I ask Phil? Like, I haven't heard what Phil's talk was. I've seen Klaus's solid talk. I've seen Kevlin's solid talk, but yours has the same name as mine. Maybe I need to change mine, but I think you stole it from me. On the last time I was on here, I told you that was the name of my talk.
Yep.
But are you praising Caesar or burying him? That's.
So, as it happens, that talk was published today, so you haven't been able to see it before today.
Put it in the show notes.
Just watch it. I watched it back earlier just to make sure I remember what I said in it, and surprisingly, I actually came out more in favour of the solid principles than I previously had thought. After I'd sort of really dug into it, because a big part of the premise of the talk was taking the criticisms that Kevlin Henney had put forward in his solid deconstruction, as well as Dan North in his every element of solid is wrong. Mm-hmm. And to really dug into it, looked at the history of it, what things actually mean. And I'm still a bit critical of some aspects, most of which we've covered, particularly the naming and also some of the internal redundancies between things. Most of the principles are just about polymorphism, and then there's the bit about separation of concerns or cohesion, really. So you can simplify that way. But most of the other criticisms, I found that they didn't actually hold up once you examined them. So now, of course, you're going to have to go and watch my talk to find out what I mean by that. But yeah, I was actually a little bit more for them than I originally set out to show.
Yeah. Can I at least now think that I influenced you positively? No.
You can believe that if you like. Absolutely. No, your talk was great as well, because you're just going into the practical application, particularly in a C++ context, and we can argue all we like about abstractly are these really the right principles, but in everyday use, you want some practical examples of how you're going to use them.
I would like to make up another acronym. Like I've been
I did that
trying.
too.
Oh, you did. Okay.
I was going to say, I put forward the plasma principles.
Plasma. And what are they?
Okay, plasma is 1 letter more.
Yeah.
Right? 6.
Let's see if I can remember them off the top of my head. I've got the P is for persistence, as in persistent data structures. And really it's more of a stand-in for immutability in general, but using persistent data structures is a big part of that. The L is for loose, as in loose coupling, so that's really the cohesion part. The first A was, I think the first one was algorithms, using algorithms instead of designing or writing everything from scratch yourself. Reference, of course, to Sean Parent and no role loops. Mm-hmm. Where did we get to?
Yes.
So the S, what did I?
Just stands for Sean
S
Parent.
for simplicity. And I did a whole talk on simplicity, so I'll just reference that for simplicity.
Wait a second. Kate Gregory did a talk on simplicity. Do we all just
I did mine
steal
first.
each other's talks? Okay.
A very different type of talk, though. In fact, my one was much closer to Rich Hickey's Simple Made Easy, which was a big influence, and heavy references in there. So if you've seen that, you know what sort of thing it's about. And that ties back into actually what Dan North was saying in his criticism of Solid. He was basically saying, well, it boils down to writing simple code. But because he'd said it in a lightning talk, he didn't really elaborate on that. But actually, if you look into what simplicity really means, it does make a lot more sense. So the S was for simplicity. The M, I just went for memory safety. That was a bit of a weaker one and much more of an implementation level thing. But yeah, still was worthwhile. And then the final A was abstractions. So we talked a lot about abstractions and how important they are. Often in discussing the solid principles, when we talk about interfaces, what we've been doing here tonight, really we're talking about abstractions. And that's like a more general concept. Interfaces are a way of expressing an abstraction, not the only way. I think
just a really question. Okay, sorry.
Yeah, no,
really
I'm
question.
finished.
So I know I didn't watch the talk, so I'm at a disadvantage. But the L and the A, the last A, so loose coupling and abstraction. This sounds like design principles. But the first one, for instance, the P, does not so much. So it's not about decoupling. It's not about dealing with abstractions of any kind. So what's the design aspect of that? And how can it replace design principles like solid?
So it's more that by taking into account immutability, or having an immutable mindset, not the mindset's immutable, but you have a mindset of implementing immutable code. Yeah, it's an implementation strategy, but it impacts your design. You have to think about it at the design stage, I think. And also frees up some of the things you have to take into account when you're designing things. If you think, well, I know that can never change and that can never change, and therefore these things don't hold. In fact, Tony was talking about objects that don't need to be objects with an interface. They can just be just a struct with some data members, because once you've taken out the mutability, you don't have to enforce or maintain invariants. You can just go with the raw data. You can basically take out the possibility of behavior actually changing anything. You don't have to guard that anymore. So just that preference for immutability changes the way you design things. So that's really what I was going for there.
Would you argue that all of these 6 are about dependency decoupling somehow?
Keep your stuff separate.
They're not all about dependency decoupling. Some of them are, some of them aren't. I'd say the main one, obviously the loose coupling, but also the simplicity. My take of simplicity is it's all about how things interconnect. Well, complexity is the unnecessary overlapping of things that shouldn't be really. So once you achieve simplicity, then you have decoupled anything that shouldn't be coupled. So back to
speaking of talks that overlap, when I did my postmodern talk at the C++ Now, Wampe Boulevard again did a talk on postmodern immutable data structures. Right, that exact idea of like you can make everything in your program immutable, and it's also sort of how, you know, the trick to that is if you have a big data structure and something changes, you have to make a copy of it. Well, underneath you don't actually make a copy of it, right? You track the changes. That's exactly the same way Sean does Photoshop, right? Photoshop, the undo stack is make a copy of the document, which is hundreds of megabytes of pixels, and put it on the stack, right? It's like, well, it doesn't actually make a copy underneath the covers, right?
Really? It doesn't duplicate all those pixels?
Yeah.
How clever.
The other thing I was thinking there is that, at work, we've been trying to make an acronym. And so far we have, I can't even remember all the letters, but ungood. And U is ubiquitous, because everyone wants ubiquitous objects. And N was nebulous, and G was global. O was omnipotent, I think. You want that class that can do everything. And I forget what the other 2 were, but it was basically looking at one of our classes in our code base and going, yes, this class is ungood. This is it's our model class that has access to everything, can do everything. You know, anything changes, it's going to go through model. Model's always changing.
So I expect that Phil will shut us down in just a couple of minutes. So it starts looking like that. So let me ask you a question, because what we are right now doing is indeed talking about design. And this is apparently a lot of fun. And there's a lot of discussion. There's a lot of different opinions. Why is there not many talks about design? Why is there many talks about features, many talks about
techniques,
etc.? Why is there not many talks about design?
Because I think I've been thinking about this a lot because it was an interesting question you'd raised earlier that you had, I think you had some numbers on it about, the number of conference talks that are about design versus features. And, I give classes, that's what I give. And I don't talk a lot about design. And the reason is I'm not comfortable giving you an objective answer. You want to not talk about operator overloading? I can tell you this is how you do it. And, those are design elements that have caused us to make these decisions, but this is best practice when you want to do operator overloading. It's coding. I can be objective about that. But when you get into design, there are certain design things like one of Scott Meyer's design things was that your classes should either be base classes or instantiated classes, and you shouldn't do both. And I think that's a brilliant design rule. And I teach that, but an overall principle like loose coupling or something like that, it's hard to know when you've got it right. It's hard to know how to apply it. It's hard to know, oh no, this is the time you want to do it, but this is the time. This is simple. We'll just make it a concrete, vocabulary class, and we're just going to implement it straightforward, as simple as possible. When do you do all those kinds of things? And that's, I think, part of it is it's less objective. There's a lot of subjectivity. And for people who can give good, entertaining talks and can be a little bit nuanced, and that's a great talk. But I wonder, look at what we've been talking about so far. We've been making fun of the fact that Tony and Phil both ended up having the same name in their talk. And we're talking about, Tony was saying, well, let's just use Sean's slides and give that talk over again. There's a lot of overlap in what we're trying to say. And a lot of times it's just a different point of view. So I think this is my problem with design in general. I love it. And if you can give me a good design principle that I can work with and I can apply in a very practical sense, I'm all over that. And I have some design guidelines I give people. But design as an overall, if you come to me with a problem, if you come to me with a specific problem, you say, well, I'm trying to call this from this and I want to encapsulate this, that's a coding issue. I can tell you how to do that. But if you just say, well, I'm trying to design something and I've got objects that are going to be like this or something like this, and I need to be able to do this, I don't know that I can give you the perfect answer. I can give you a workable one, but somebody else could come along and say, well, why don't you do it this way? And I might say, oh, now that I see it, that's the way. How did you get there? I think it's the difference between maybe art and craft, in the sense that if I tell you, you're a tailor, make me a shirt like this, and your craftsmanship is excellent, but what if I say design a new kind of shirt that nobody's ever seen before? Well, that's not craftsmanship, that's art. And that's the difference, I think, between design and coding, that I can pretty much give you a concrete, specific, this is the way to write this as code. But in the design world, I can, when I see it, I can say, oh yeah, that's a brilliant design. But I can't give you the steps to come at that. And I can for code. You're trying to solve a problem, I can give you the steps to do that in code. But if it's a design issue, I can give you guidelines. I can give you things to weigh back and forth. What is the correct?
There's one answer, right, to all C++ and programming questions. The answer is it depends. and especially in C++. Yeah, especially in C++. Like some other languages, there are the designs that everyone uses, right? Like Java tends to have certain ways. It's like, you just do it this way. It's okay. I'll use the visitor pattern. Everyone knows it. Everyone uses it. In C++, it's always a trade-off. And some languages don't give you the power to have the trade-off.
Right. Yeah.
But C++ does. And that's the thing about C++. And then it's like, okay, so how do I solve this problem? It's like, it depends. Did you want to, like, are you looking at performance? You're looking at maintaining the code? Are you looking at, memory? Which part of performance?
Simplicity.
Yeah, all these things. And it's like, but I do try to give, that's what my talks, the other thing of why don't people give these talks? I think because they're really hard. That's my answer. It's like, and the other part is, honestly, when I give a talk, I expect to reach one person in the audience, and that's about it, right? I expect there's this one person, yeah, and it's actually, I am always trying to just connect to Phil. That is the one. He's the one person.
Thanks, Tony.
And I keep trying, and the guy just doesn't get it. I mean, like, geez.
Bill always gives him a 5. Everybody else gives him 1.
but I also have this theory that for the most part, programmers program the way they think, and you're not really going to change the way they think very much. Like certain people are always going to write, big functions because they like to see everything at once, and certain people are going to abstract because they like to think that way. But what happens is I give a talk, and there's one person in the audience who was just at that point in their code base where they had this thing and they weren't sure about something, and they see one of my slides and they go, aha, that's what I was looking for. Mm-hmm. And they would have gotten it anyhow. They would have got there, right? They were, and like some programmers, I think, don't look at their code. They don't self-reflect on the code. They just like, did it work? Did I get the job done? Can I move on to the next feature? And that's fine, because you need that. You need people to actually ship the product. But then you get this other set that self-reflect, and eventually they'll probably catch on to what was wrong. Like, how did I end up in this spot? I know the code I end up with is bad. How did I get here? And you do a talk, and they go, oh, wait, I see it. But a design talk, you only get that with like one person of the whole audience. You get a whole bunch of people in the audience who are like, oh yeah, that I've seen that before. Like half of my audience tends to be committee members, right? And they're just there for the jokes. They have already seen all this stuff. They've got their own take on it, and I'm just trying to entertain them. And then you get another half. I'm sure there's people in the audience who are just like, I don't know what you're talking about, because I'm not at that. I like, you're using words like dependency injection. I don't even know what that means. Or if I understand the words, but I haven't experienced it enough to get a real feel for how painful it is to get it wrong, right? And you're not going to reach those people either. Whereas if you just do a talk on, like I do talks on lock-free programming, which also I hope not to reach anybody in the audience. but it's very much technique. And it's just like, here's how compare exchange works, and here's how these things work. Same with, like John said, like, here's how operating overloading works. Yep. And honestly, I've had people ask me to do that kind of training, and I'm just like, I can't do that kind of training. It's necessary, and it's important stuff. And
Klaus and I will take it. When someone asks you to do that, refer them to Klaus or I or Phil.
Yeah, exactly.
We'll do that training.
So I'm actually trying to figure out how do you do training at the design level, right? Like, you can't just give them little examples and things like that. Yeah.
Phil knows.
Yeah, you should all come to my TDD training course, because it's all about design, test-driven design.
Yeah, sure.
I'm actually also trying to talk about design, but my approach is really to show the opposite sides. So I do show an object-oriented design. I show value-based design. I compare them live in terms of performance. I change the designs. I show how this works, how easy it is and not. So I do not try to show the solution. I usually show many solutions. This is probably why
the it depends. The it depends is there for you, right? You're like, here they all are. Pick the one that works. Yeah, I really like your talk.
So yeah, we should build a 5-day class. It's just called C++. It depends.
There's only one slide. It just says.
But no, there's only one point, and then there's 1,000 slides that are examples of why sometimes you. Anyway, we do have to wrap it up. I think we're a little over time here, but wow, this is a great group, and I wish we could. Let's come back once a month and solve all the world's problems. Is there anything else we particularly need to say? What do we want to say about C++ on C? Is it floating off on an iceberg?
No. No change since we last spoke. The call for speakers is still open for a couple of days, and early bird tickets are open.
All right. Cross our fingers if we can get this thing out before C++ Now, because you definitely want to go to C++ Now. You hear Tony's keynote. The program is great this year. We're going to have a lot of the favorites coming back, like Tony, a lot of people, but we've also got some new people. The fact that it's online only means that there are people who can attend who would never have been able to. And the future of C++ Now is that we'll probably not be hybrid. In fact, I'm pretty sure it won't be hybrid. And so this is, if you can't travel to Aspen, this is your one chance in your lifetime to go to C++ Now, which is a once in a lifetime kind of conference. So you definitely want to do that. So that's my spiel for that. And do you guys have anything you want to talk about, Tony or Klaus?
I was going to say exactly that. I was waiting. I knew you were going to say C++ now, but I've been thinking about this for weeks. There's a lot of people I know are just like, oh, I can't make it to that conference. It's like, now you can. You can make it to everyone. I don't hide this. It is my favorite conference. I like all the other ones. This is my favorite conference. So now's your chance. And being online, it won't be exactly the same as why it's my favorite conference. But I still think it's going to be great. So here's a chance to at least get a feel for what it is, and then you'll figure out how to actually be there in person next time. Oh, and then I want to bug John about I've dreamt of keynoting C++ now in Aspen. Oh
well, if you do a good job this time, Tony, we might have you back. We have had the same keynote speaker back, more than once. It's historically.
I have a talk in the back of my mind only for C++ now keynote, because I can't imagine it working anywhere else. But someday.
C++ now is the kind of conference that I can understand somebody making that comment.
It's unique.
So anyway, we do have to wind it up. I'm going to ask you guys to join me in wishing everyone safe coding. And if we follow the kinds of guidelines that we've been talking about in this session, everyone will be coding safely, or at least it's their responsibility. We've given them the tools, right? I hope so anyway. So everyone, thanks for watching, and safe coding.
Safe coding.
Safe designing.